Module 5, Elasticity. Elasticity of demand. Elasticity, an economics concept that measures responsiveness of one variable to changes in another variable. Types of elasticity. Price elasticity of demand. Price elasticity of supply. Income elasticity of demand. Cross-price elasticity of demand. Elasticity of demand continued. Elastic and inelastic demand. Elastic demand, a high responsiveness of quantity demanded or supplied to changes in price. Example, the store owner raises prices, she can expect that the quantity demanded will drop, but she might not know how sensitive customers will be to the change. Inelastic demand, a low responsiveness by consumers to price changes. Example, cigarette taxes and smoking rates. The greater the amount of the tax increase, the fewer cigarettes are bought and consumed. Elastic and inelastic demand analysis. Factors helping to predict product demand as more or less elastic. Substitutes, necessities versus luxuries, share of the consumer's budget, short run versus long run, competitive dynamics. Examples of elastic and inelastic demand. Which of the following products have elastic demand and which have inelastic demand? Gasoline, college textbooks, coffee, airline tickets, concert tickets, soft drinks, medical procedures. Calculating elasticity and percentage changes. Definitions. Elastic demand, when the calculated elasticity of demand is greater than 1, indicating a high responsiveness of quantity demanded or supplied to changes in price. Elastic supply, when the calculated elasticity either of supply is greater than 1, indicating a high responsiveness of quantity demanded or supplied to changes in price. Inelastic demand, when the calculated elasticity of demand is less than 1, indicating a 1% increase in price paid by the consumer leads to a less than 1% change in purchases, and vice versa. This indicates a low responsiveness by consumers to price changes. Inelastic supply, when the calculated elasticity of supply is less than 1, indicating a 1% increase in price paid to the firm, will result in a less than 1% increase in production by the firm. This indicates a low responsiveness of the firm to price increases and vice versa if price drops. Examples, this one we already looked at. Calculating elasticity and percentage changes. Definitions continued. Midpoint elasticity approach. Most accurate approach to solving for elasticity, in which the growth rate or percentage change in quantity demanded is divided by the average of the two quantities demanded. Point elasticity approach. Approximated method for solving for elasticity, in which the initial quantity demanded is subtracted from the new quantity demanded and then divided by the initial price. Unitary elasticity, when the calculated elasticity is equal to 1, indicating that a change in the price of the good or service results in a proportional change in the quantity demanded or supplied. Calculating elasticity and percentage changes. Calculating elasticity. The formula for calculating elasticity is price elasticity of demand equals percent change in quantity over percent change in price. Here's an example. For every 10% increase in the price of a pack of cigarettes, the smoking rates drop about 7%. Using the formula, we get a -7 over 10%. Percent change in quantity goes on top, percent change in price goes on the bottom, and we have a -0.7%. Calculating elasticity of percentage changes. Inelastic. What does the number -0.7 tell us about the elasticity of demand? A negative sign reflects the law of demand. At a higher price, the quantity demanded for cigarettes declines. The result of less than 1 says the size of the quantity change is less than the size of the price change. It would take a relatively large price change to cause a relatively small change in quantity demanded. Consumer responsiveness to a change in price is relatively small. When the elasticity is less than 1, demand is inelastic. Calculating elasticity and percentage changes, elastic and unitary. Different products, different price elasticities of demand. If the absolute value of the elasticity of a product is greater than 1, the change in the quantity demanded is greater than the change in price. Greater than 1 indicates a larger reaction to price change, which we describe as elastic. If elasticity is equal to 1, it means that the change in the quantity demanded is exactly equal to the change in price. So the demand response is exactly proportional to the change in price, and we call this unitary elasticity, because unitary means 1. Calculating elasticity and percentage changes. Calculating percentage changes and growth rates. Formula for computing growth. Percentage change equals change in quantity over quantity. Example, a job pays $10 per hour. At some point, the individual doing the job is giving a $2 per hour raise. The percentage change or growth rate in pay is $2, the change, over $10, the original amount, 0.2. Solve for elasticity using the growth rate of the quantity demanded and the percentage change in price in order to examine how these two variables are related. Use the point elasticity approach with product quantity demanded at 100 and then move to 103. So 103 minus 100 over 100, that's a 3% growth. Now let's try the midpoint elasticity, midpoint or arc elasticity approach. It uses the average price and the average quantity over the price and quantity change. Same example, a job pays $10 per hour. At some point, the individual doing the job is giving a $2 per hour raise. The percentage change or growth rate in pay is $2 over the $10, 0.2 or 20%. Solve for elasticity using the midpoint or arc elasticity approach with product quantity demanded at 100, then move to 103. 103 minus 100 over 103 plus 100 divided by 2. So we take 3 over 101.5 and we get 0.0296 or 2.96 growth. Calculating the price elasticities using the midpoint formula. Percent change in quantity, Q2 minus Q1, all of that over Q2 plus Q1 divided by 2. Percent change in price, P2 minus P1, all of that over P2 plus P1 divided by 2. The midpoint method using the average percentage change of both quantity and price. There are two formulas used for the midpoint method, the percent change in quantity and the percent change in price. The advantage of this midpoint method is that one obtains the same elasticity between price points, whether there is a price increase or decrease. Calculating price elasticities using the midpoint formula continued. Calculate elasticities from points B to A. Step 1. Use price elasticity of demand formula. Percent change in quantity over percent change in price. Step 2. From the midpoint formula, we know percent change in quantity is Q2 minus Q1 over Q2 plus Q1 divided by 2. And percent change in price is P2 minus P1 over P2 plus P1 divided by 2. Step 3. Use the values provided in the figure as price decreases from 70 at point B to 60 at point A in each equation. Percent change in quantity, 3,000 minus 2,800, all of that over 3,000 plus 2,800 divided by 2. Percent change in price, 60 minus 70, all of that over 60 plus 70 divided by 2. Divide the percent change in quantity by the percent change in price. We'll put 6.9 over 15.4. And then we should get negative 0.45. That's step 4. Those values can be used to determine the price elasticity of demand. Clearly, that would be inelastic. Calculating price elasticities using the midpoint formula. Elasticity is not slope. Common mistake to confuse the slope of either the supply or demand curve with its elasticity. The slope is the rate of change in units along the curve, or the rise over run, change in y over change in x. The price elasticity, however, changes along the curve. Elasticity is the percentage change, which is a different calculation from the slope, and it has a different meaning. Closer to 0, it'll be more elastic. As you get out further along the quantity axis, it becomes less elastic. Categories of elasticities. Definitions. Relatively elastic. The percentage change in quantity demanded is greater than the percentage change in price. Measured price elasticity of demand is greater than 1 in absolute value, relatively. Relatively inelastic. The percentage change in quantity demanded is less than the percentage change in price. Measure price elasticity of demand is less than 1 in absolute value. Categories of elasticity definitions continued. Unitary elastic, when a given percentage price change in price leads to an equal percentage change in quantity demanded. Perfectly or infinitely elastic, the extremely elastic situation of demand or supply where quantity changes by an infinite amount in response to any change in price. Horizontal in appearance. Perfectly inelastic, the highly inelastic case of demand in which a percentage change in price, no matter how large, results in zero change in the quantity. Thus, the price elasticity of demand is zero. Vertical in appearance, relatively. Categories of elasticity. Demand is described as elastic when computed elasticity is greater than 1, indicating a high responsiveness to changes in price. Computed elasticities that are less than 1 indicate low responsiveness to price change and are described as inelastic. Unitary elasticities indicate proportional responsiveness of demand. In other words, the percent change in quantity demanded is equal to the percent change in price, so the elasticity equals 1. Table 1, 3 categories of elasticity: elastic, inelastic, and unitary. You can go through and see if there's something, then this, and what it's called. The definitions are here again. Categories of elasticity continued. Both elastic and inelastic are relative terms, as shown in Figure 1. As one moves down the demand curve from top left to bottom right, the measured elasticity is much greater than 1, very elastic, then just greater than 1, somewhat elastic, then equal to 1, unitary elastic, then somewhat inelastic, less than 1, and then finally much less than 1, very inelastic. Note that the epsilon symbol, that E that looks backwards, is often used to represent elasticity. Categories of elasticity: polar cases. 2 extreme cases of elasticity: when computed elasticity equals 0, when computed elasticity is infinite. Note, though perfectly elastic and perfectly inelastic curves correspond to horizontal and vertical curves, remember that in general, elasticity is not the same as slope. Perfectly or infinitely elastic demand curve refers to the extreme case in which the quantity demanded increases by an infinite amount in response to any decrease in price at all. Similarly, quantity demanded drops to 0 for any increase in price. A perfectly elastic demand curve is horizontal, as shown in the figure to the right. Perfectly elastic demand is an all or nothing thing. Perfectly inelastic demand is an extreme case. Necessities with no close substitutes are likely to have highly inelastic demand curves. This is the case with life-saving prescription drugs like insulin. A specific quantity of insulin is prescribed to the patient regardless of a price increase or decrease. The same quantity is needed to stay alive. Perfectly inelastic demand means that quantity demanded remains the same when price increases or decreases. Consumers are completely unresponsive to changes in price. Price elasticity of supply is the percentage change in the quantity of a good or service supplied divided by the percentage change in price. Measures how much quantity supplied changes in response to a change in price. Looks at how producers respond to a change in the price instead of how consumers respond. Continuing along, calculate the price elasticity of supply from point A to point B. Assume that an apartment rents for $650 per month, and at that price 10,000 units are offered for rent, as shown in Figure 2 to the left. When the price increases to $700 per month, 13,000 units are offered for rent. By what percentage does apartment supply increase? What is the price sensitivity? Step 1. Use price elasticity formula. Percent change in quantity over percent change in price. From the midpoint formula, we know percent change in quantity, Q2 minus Q1 over Q2 plus Q1 divided by 2. Percent change in price, P2 minus P1 over P2 plus P1 divided by 2. Step 3, use the values provided. So the percent change in quantity supplied, and by the way, I will go back and change that. It says demand in step 1. 13,000 minus 10,000 over 13,000 plus 10,000 divided by 2. The percent change in price, 750 minus 600, 750 plus 600 divided by 2. When we put this all together in step 4, we get 3.53. That would be elastic. Income elasticity, cross-price elasticity, and other types of elasticities. Elasticity, how a percentage change in one variable causes a percentage change in another variable. Elasticity does not just apply to the responsiveness of supply and demand to changes in the price of a product. Quantity demanded depends on income, tastes, preferences, population, expectation about future prices, and the prices of related goods. Quantity supplied depends on the cost of production, changes in weather and natural conditions, new technologies, and government policies. Elasticity can be measured for any determinant of supply and demand, not just the price. So for income elasticity of demand, for most products, most of the time, the income elasticity of demand is positive. The percentage change in the quantity demanded divided by the percentage change in income. Here's the formula. Income elasticity of demand, a rise in income will cause an increase in the quantity demanded. These goods are referred to as normal goods. For a few goods, an increase in income means that one might purchase less of the good. When the income elasticity of demand is negative, the good is called an inferior good. As your income goes up, you buy less of it because you can afford better. Cross-price elasticity of demand refers to the idea that the price of one good is affecting the quantity demanded of a different good. Complement goods have negative cross-price elasticities. If good A is a complement for good B, like coffee and sugar, then a higher price for B will mean a lower quantity consumed of A. Substitute goods have positive cross-price elasticities of demand. If good A is a substitute for good B, like coffee and tea, then a higher price for B will mean a greater quantity of A consumed. Continuing on, we could calculate cross-price elasticity of demand. It's the percentage change in the quantity of good A that is demanded as a result of a percentage change in the price of good B. So here's the formula: percentage change in quantity demanded of good A over percentage change in price of good B. Elasticity in labor and financial capital markets. Wage elasticity of labor supply, the percentage change in hours worked divided by the percentage change in wages. The formula is as follows: elasticity of labor supply equals percent change in quantity of labor supplied over percent change in wage. Interest elasticity of savings, the percentage change in the quantity of savings divided by the percentage change in interest rates. The formula is as follows: interest elasticity of savings, percentage change in quantity of financial savings over percent change in the interest rate. Expanding the concepts of elasticity. The elasticity concept does not need to relate to a typical supply or demand curve at all. Whatever context elasticity is invoked in, the idea always refers to a percent change in one variable. The idea is almost always price or money variable and how it causes a percentage change in another variable, typically a quantity variable of some sort. Here are the formulas, so you can go back and refer to this again in Table 1 for each one of the types of elasticities. Elasticity and total revenue. Studying elasticities is useful for a number of reasons, pricing being the most important. The key concept in thinking about collecting the most revenue is price elasticity of demand. Total revenue is price times the quantity of tickets sold, for example, if we're looking at things like parking. Price elasticity and demand. Again, we have another way of looking at all of the different ways that revenue will be affected by if there's elastic, unitary, or inelastic. So for demand being elastic, when you have a percent change in quantity demanded that's greater than the percent change in price, we will see for a given increase in percent of price change, we'll have a more offset of a larger percent fall in quantity, so total revenue falls. For a given percent fall in price will be more than offset by a larger percent rise in quantity, so total revenue rises. Let's go ahead and look at inelastic. For a percent change in quantity demanded, there's a less than that percent change in price. So for a given rise in price, it will cause a smaller fall in quantity, and that means total revenue, price times quantity, rises. Given the percent fall in price, it will cause a smaller rise in quantity, so that total revenue, P times Q, falls. Elasticity, costs, and customers. What happens if the firm's production costs change? What is the impact on customers? If the cost of a key input rises, can the firm pass along these higher costs to consumers in the form of higher prices? If new and less expensive ways of producing are invented, can the firm keep the benefits in the form of higher profits, or will the market pressure them to pass along the gains to consumers in the form of lower prices? The price elasticity of demand plays a key role. Here we see elasticity, cost, and customers continued. How would a technological breakthrough in aspirin production impact the market if it were inelastic? Here that would be where there's a very steep demand curve. How would a technological breakthrough in aspirin production impact the market if it were elastic? So the idea is to take a look at the steep inelastic demand curve and see that if supply shifts to the right, there's not much of an increase in quantity, there's a pretty big drop in price. As opposed to when you have a relatively flat or elastic demand curve for the same shift in supply, for the same shift to the right in supply, you have a relatively small decrease in price, but a bigger increase in quantity. So elasticity affects the outcome. So applying elasticity in the real world, what happens to the housing rental market when there is a big boom in apartment production in your community? You can think it through if demand is elastic and inelastic. And here we can go through this example, long run and short run. Elasticities are generally lower in the short run than in the long run. The reason why is there isn't enough time to go ahead and develop substitutes. On the demand side of the market, it can sometimes be difficult to change quantity demanded in the short run. It's easier over the long run as consumers develop different tastes and preferences. The elasticity for demand for energy is somewhat inelastic in the short run, but it gets much more elastic in the long run as there's new technologies that are developed, substitutes, wind, solar, etc. Elasticity, costs, and customers, long run versus short run, continued. For the supply side of the markets, producers of goods and services typically find it easier to expand production in the long term, several years rather than in the short run, which is a few months. In the short run, it can be costly or difficult to build a new factory, hire many new workers, or open new stores. But over a few years, all of these are possible. In most markets for goods and services, prices bounce up and down more than quantities in the short run, but quantities often move more than prices in the long run. The underlying reason for this pattern is that supply and demand are often inelastic in the short run, so that shifts in either demand or supply cause a relatively greater change in prices. Since supply and demand are more elastic in the long run movements in prices are more muted, while the quantity adjusts more easily in the long run. Tax incidence. Elasticity and tax incidence. The analysis of how a tax burden is divided between consumers and producers is called tax incidence. Who pays the tax? It's not actually the person who pays it, it's where does the burden of it fall. Tax incidence depends on the price elasticities of supply and demand. Typically, the tax incidence or burden falls both on the consumers and the producers of the taxed good. To predict which good will bear the most burden, examine the elasticities of demand and supply. Continuing on, when the demand is inelastic, consumers are not very responsive to price changes, and the quantity demanded reduces only modestly when the tax is introduced. That would be here in panel A. When tax is added in a market with inelastic supply and sellers have no alternative other than to accept lower prices for their businesses, taxes do not greatly affect the equilibrium quantity. Here you are in B. Quick review. I'll let you guys go over this on your own because this has gotten long. Thanks.